So now we make a sign chart of the first and second derivatives. Let's see. Our three relevant points are 0, 4/3, and 8/3. 4/3 is 1 1/3, so that's about 1.3. 8/3 is 2 2/3, so that's about 2.6. Right. The derivative equaled 0 here and here. Oh, that's the second derivative. I haven't labeled anything yet, but I always put the first derivative on top, second derivative on bottom. First derivative equaled 0 here and here, second derivative equaled 0 here. If we test the second derivative test, we can use that to work our way upwards. We're going to say, what's f double prime of 0? It is, here's our formula, 8 minus 6 times 0 is 8 is positive. We're going to test f double prime of anything to the right of 4/3, so 2 works. 8 minus 6 times 2 is 8 minus 12 is negative, so we are negative here. What's going on at this point? At this point there's a function that equals 0 whose derivative is negative, so we must have been positive to the left of it and negative to the right of it. What's going on here? F prime is a function that equals 0 and its derivative is positive, so it must have been increasing, so negative on the left and positive on the right. Hey look, this all agrees with each other, everything looks good. What are the questions that they asked? State the intervals on which it's increasing, decreasing, concave up, concave down. Oh, state the maxima and minima and inflection points. I guess let's answer these. At this point, we were decreasing, then increasing, so that's a local min. It's at x equals 0. We got a local max. At this point, x equals 8/3. We got an inflection point. It is an inflection point because we actually did switch sign. We're not worried about positive on one side, negative on the other side. Anything that switches is an inflection point. That's x equals 4/3. When is it increasing? The function is increasing on 0 to 8/3. When is it decreasing? It's decreasing on 2 intervals. That's when the derivative is negative. It's negative infinity to 0 and 8/3 to infinity. When is it concave up? It's concave up from negative infinity to 4/3. It's concave down from 4/3 to plus infinity. And this is all just reading off what we know about the first and second derivative. You're concave up when the second derivative is positive, down when it's negative, increasing when the first derivative is positive, decreasing when the first derivative is negative. There's that one. Find the global max and min of this function on the region x greater than 0. This is not a closed interval, so these things may not exist. Make sure we're doing calculus. You can make a graph and confirm your answer, but just saying, hey, I graphed it is not going to get you many points on this. I want derivatives. This is 5x to the 4 plus x to the negative 1. The derivative of that function is 20x cubed minus x to the negative 2. We'll go ahead and take the second derivative. The second derivative is 60x squared minus positive 2x to the negative 3. This is 60x squared plus 2 over x cubed. That's positive. And that's positive as long as x is positive, which is all we care about. Positive plus a positive is positive. Hey, f double prime is always positive. So that means any critical point is the global min. Min, positive second derivative is concave up, yeah, is a global min. Because our interval is from 0 to infinity, I guess it could be like this, or it could be like this, or it could be like this. In any of those cases, there is no max, because the function doesn't stop at 0. It doesn't stop at infinity, or more likely it doesn't stop at either. So no matter what, it's going to increase to forever, some on one end or the other. So there's no max. Where's the min? It's at the critical point if there is one. We take the derivative, set it equal to 0. 20x cubed minus 1 over x squared. When do you equal 0? 20x cubed equals 1 over x squared. 20x to the 5th equals 1 when I multiply both sides by x squared. X to the 5th is 1 over 20, so x is the 5th root of 1/20th. So there's no max, and the min is at x equals the 5th root of 1/20th. Cool. Also, a heads up on how I'm writing these. These problems are done so that the place where the minimum happens, it's going to be hard to figure out where that is without doing the calculus. You can graph it and see there's a minimum at 0.0 whatever that number is, but it's going to be hard to figure out that that number is the 5th root of 1/20th without doing the calculus. It's part of the reason these numbers are obnoxious. Here's a production level. I have a marginal cost of this. I have a marginal revenue of that. I have a total cost of this. If we want to maximize profit, then I'm thinking about what's bigger, the marginal cost or the marginal revenue. At this production level of 1500, marginal cost is 17.5, marginal revenue is 19. So if I make one more unit, it will bring in $19 and it will cost me $17.50. Since marginal revenue is bigger than marginal cost, the maximum profit will occur above 1,500 units. What about the average cost? To think about the average cost, we want to compare average cost versus marginal cost. Marginal cost they gave us is 17.5. The average cost they didn't give us. It's the total cost divided by quantity. Total cost is 22.5. Quantity is 1,500. That's 22 over 15, that's 15. The average cost at this production level is 15. The marginal cost is 17.5. So we've been making a bunch of units. We've been paying $15 a piece for them. If we made one more, that one would cost $17.50. Is that one a good deal? No, that one is a bad deal. That costs more than the average. So making that extra unit will lower our average cost. Will increase our average cost, which is bad for us. We don't want our average cost to go up. And making the last unit we did was a bad deal also. We shouldn't have made it. So to lower our minimum average cost, probably is below 1,500 units. Since marginal cost is bigger than average cost. Cool. Here's our demand function. Write a formula for revenue. Okay, revenue is price times quantity. Maybe I should read the whole question first. And find the maximum possible revenue. Okay, I can do that. I need to say how I know my answer is the maximum. R of Q is going to be, Q is just the letter Q, and P is that thing they gave us a formula for. 200 minus 0.03 Q squared. I'm going to take a derivative and set it equal to 0. I think I might as well simplify this first. 200Q minus 0.03 Q cubed. Marginal revenue is the derivative of that, is 200 minus 0.09 Q squared. Let's go ahead and take a second derivative, because that's usually the easiest way to say I know it's a maximum. Second derivative is just negative 0.18 Q. Hey, that's less than 0 on Q positive, which is all we care about. We don't want to make negative units. Since R double is negative, on cube.